fast it's going, man. Look how fast.
Launch. You have a liftoff.
Off we go. I got it? Okay, thanks.
There it is, straight out. Just coming out. There it is. I lost him. They're going to reappear up here somewhere.
Three, 2, 1. We have liftoff.
There it is, right there. There they are, right above us. See them? Right next to each other, right here.
Right there. Yeah. Straight up.
صدق الله العظيم. وماذا عن الذين يدعون إنهم خرجوا من الأرض مثل ناسا والصين وغيرها؟ هل هم فعلا استطاعوا أن يخرجوا من الأرض؟
Now, one thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go. There's no place to throw your trash.
Two special guests from International Space Station, Terry Virts, the current ISS commander, and Samantha Cristoforetti, the first Italian female astronaut in space. And what comes after the International Space Station once its mission is over? How do we ensure the presence of humans in space?
Well, that's a great question. The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to and we're building these building block components in order to allow us to do that eventually.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before, to an asteroid or even onto Mars. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right. No astronauts will be aboard. The spacecraft is loaded with sensors to record and measure all aspects of the flight in every detail. It all begins with launch, aboard a Delta IV as the spacecraft and the upper stage begin their first lap around Earth. Mission Control in Houston is monitoring the progress of the flight. Orion's over 100 miles up and going about 17,000 miles per hour. Just as it passes over the Indian Ocean, we lose communication. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
All right, we now have a picture from Apollo 11, so let's go to Houston for the conversation between the spacecraft and Houston, and we'll see these pictures. There's the Earth.
The Earth from 130,000 nautical, or about 149,000 statute miles.
Though the federal government would have you believe that this is a view of Earth from a distance out of the spacecraft's window as it nears the moon, it is not. What they have ingeniously done is placed the camera at the back of the spacecraft and centered the lens on a circular window in the foreground, outside of which it is completely filled with the Earth in low orbit. The circumference of the window then appears to be the diameter of the Earth at a distance, with the darkened walls of the spacecraft appearing to be the blackness of space around it. That is why they wanted the interior dark and blocked out the sun from entering through the other windows. Here you can see the extruded window, probably 2 inches thick at the bottom. This is because the Earth's shine is coming in at a downward angle. It also causes the Earth to appear to be an irregularly shaped circle, for you are seeing the outside of the window at the bottom and the inside of the window at the top, which together form 2 different sized halves of a circle. Subsequently, this take was never used. As they perfected the shot, a crescent-shaped piece of black material was inset slightly into the window to create the illusion of the Earth's terminator line dividing night and day. It is uncannily convincing. During this segment, intended to be edited and played back later for the worldwide television audience, dated July 18, 1969, Neil Armstrong condemns himself as he states that he is 130,000 miles out, or halfway to the moon, as the NASA flight log also states on this date. the very bright and near Earth out the window. Here is the slate for the 19th of July, and the same shot of trickery on the 19th of July, and then the 20th, and the same misleading shot on the 20th. Later that evening, they were said to be walking on the moon. How can this be when they were in Earth orbit only 9 hours earlier, and the moon is some 3 days' journey away? Furthermore, if they genuinely went to the moon, why would they be faking any part of it? Why this trickery with the window? By faking being halfway to the moon, it becomes apparent that they did so because they could not even go halfway.